This example problem is one of a conical pendulum, which in reality is just a two-dimensional dynamics problem with the addition of centripetal force, so circular motion involved. So if I draw out what happens here, if we have our conical pendulum, we know that the pendulum's moving in a circle, and then if this is the center of the circle, this is, let's say, the pole that we have. It's going to be connected down here to whatever the object is. So if this is a string, and let's just say this is a rubber stopper, or whatever it is, this rubber stopper is going to be moving along in a circle. Now, in terms of the forces we have, I know I have an inwards force, because I have to have an inwards force because it's moving in a circle. I also know I have the force of gravity that's going downwards. The question is, what is this inwards force? This inwards force is actually just the component of tension that we have, because I have the tensional force that's caused by the rope. And the tensional force has our components on it. It has a vertical component and it has a horizontal component. So the vertical component is, I'm just going to call Ty, and the horizontal component is just what I'm going to call T sub x. So because I know this is moving in a horizontal circle, that's what the conical pendulum does, moves in a horizontal circle, that means that it's only that x component that's equal to my centripetal force. What it means then is that the other components of the forces, because we have to look at the other forces as well, this y component of tension and this force of gravity, they have to be balanced because it's not moving up or down at all, so that means that these two have to be equal to each other. So it means that the y component is equal to f sub g. So the way I can figure this out is just as follows. I know Tx is equal to mv squared over r, because that's the centripetal force. I know that T sub y is equal to m times g, because that's just the force of gravity. I don't know what the mass is, but I do know what the acceleration due to gravity is. I do know what the velocity is. I don't know what the radius is. But if I plug this in, I have T sub x is equal to m times 4 meters per second squared divided by r. And I know that T sub y is equal to m times 9.8 meters per second squared. Now here's the next thing. If I really think about what these are, this is Tx, this is Ty. Those are just components. I know the angle is 20 degrees from the vertical, which means if I really set this up as a triangle again, and if I just look at my components, if this is the vertical, this is 20 degrees from the vertical, this is going to be Tx, this is going to be Ty, I can just use a trig ratio to set this up. So 20 degrees, I can do the tangent of 20 degrees equals Tx over Ty. So the tangent of 20 degrees is equal to the x component divided by the y component. Now what that means I can do is, now that I have these as basically reduced as much as I possibly can, I'm going to substitute them in. So the tangent of 20 degrees is equal to, and if I put Tx on the top, that's 16 meters squared per second squared times m divided by r. That entire thing divided by 9.8 meters per second squared times m. And if you look at what happens here, the m's cancel out. So the mass doesn't matter. The mass cancels out. So what I'm left with here is that the tangent of 20 degrees is equal to 16 meters squared per second squared over r divided by 9.8 meters per second squared. All I have to do is multiply both sides by 9.8 meters per second squared, and I have 9.8 meters per second squared times the tangent of 20 degrees is equal to 16 meters squared second squared divided by r. Now, it's just a proportion. I can cross multiply and I can solve for r. So I'm not going to go through the entire math steps here. That way you should be able to figure that out. So if I just do what I need to do here, I get a radius of 4.486 meters, which means that the length of the string is not 4.486 meters, that means that the component here, the radius, is 4.486 meters, and that's also important to understand. So this part, this distance here is 4.486 meters, which means if I wanted to know the length of the string, if I set up my triangle again, I know the angle is 20 degrees. I know this is 4.486 meters, and I need to find L. That's going to be the length of my string there. So I can just do sine. So I know the sine of 20 degrees is equal to 4.486 meters, opposite, divided by the hypotenuse, which is L. Again, just cross multiply. So 4.486 divided by the sine of 20. That gives you a length of your string of 13.116 meters. Kind of a long string for that to occur, but it's actually a pretty fast velocity to be spinning this pendulum at with a 20-degree angle. So it is going to have to be kind of a long string for that to occur. But it does involve a little bit of trick, a little bit more than just a little, I should say. It involves our tangent, it involves our sine, and you just have to make sure that you understand how to reduce everything to get your final answer.